Question 3-5, Day 1. Arithmetic sequences as linear functions. Essential question. How do you write an equation for an arithmetic sequence? So an arithmetic sequence is a sequence with a pattern involving the same number being added or subtracted over and over. So the key word there is added or subtracted. So it's like a list of terms, and you are either adding the same number each time or subtracting the same number each time. So for example, if you have 5, 10, 15, 20, that is your sequence. That is an arithmetic sequence because you are adding the same number over and over. You are adding 5 each time. If you are adding a different number each time, that would not be considered an arithmetic sequence. An equation for an arithmetic sequence is f of x equals mx plus b. And that is our equation when x equals 0, 1, 2, 3. It is also important to note that an arithmetic sequence is linear. And that is because anything written in the form mx plus b is linear. So if you graph an arithmetic sequence, you will get a line. All right. So on this first slide, we are going to find the common difference and the next 3 terms in each sequence. So first of all, the common difference is what you are adding or subtracting. So I'm going to put that over here. So what are we adding or subtracting each time to get the next term? And then we are going to find those next 3 terms. So looking at the first one, I have 1, 5, 9, 13. So I'm going to figure out what number am I adding or subtracting to get to the next term. Well, this is all positives. They are getting bigger. We are adding 4 each time. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. So our common difference is 4. And then going from the 13, I'm going to continue adding 4 to find my next 3 terms. So 13 plus 4 is 17. 17 plus 4 is 21. 21 plus 4 is 25. All right, now I have a set of negatives. Negative 3, negative 5, negative 7, and negative 9. So keep in mind, these numbers are getting smaller. Negative 5, negative 3, negative 5, negative 7, negative 9 on a number line, those are getting smaller. So if numbers are getting smaller, I am subtracting. So I'm subtracting 2 each time. Negative 3 and negative 2 make negative 5. Negative 5 and negative 2 make negative 7. Negative 7 and negative 2 make negative 9. So I am subtracting 2. So then from negative 9, I'm going to find the next 3 terms. Negative 9 minus 2 is negative 11. Negative 11 minus 2 is negative 13. Negative 13 minus 2 is negative 15. All right, negative 12, negative 6, 0, 6. Those numbers are getting bigger. So that means I must be adding something. Sometimes it can be easy to look at the positives and ignore the negatives to figure out what you are adding or subtracting. So to go from 0 to 6, I am adding 6. And let's see if that makes sense. Negative 6 to 0, I am adding 6. Negative 12 to negative 6, I am adding 6. You can put a plus there in front, but you don't need to. So like on the first one, we just wrote a 4. You can write plus 4 if you want. You can write plus 6 if you want, or you can just write the positive. All right, so ending with 6 in our sequence, so let's add 6 more, and I end up with 12. Add 6 more and I have 18. Add 6 more and I have 24. All right, now we have some decimals. So 7 to 5.5 to 4 to 2.5. These numbers are getting smaller, so we know we are subtracting something. If you're having a hard time figuring out what it is, you can take the first two numbers and do 7 minus 5.5. That will give you the common difference of 1.5. So we know we are subtracting 1.5 each time. So 2.5 minus 1.5 is 1. 1 minus 1.5 is negative 0.5. And that minus 1.5 is negative 2. All right, last one of this first problem type. Negative 7.7, negative 5.5, negative 3.3. These numbers are getting bigger. If the decimals throw you off, just look at the first part. Negative 7, negative 5, negative 3. That is getting bigger, so we are adding. If you're not sure what you are adding, you can take negative 7.7 and subtract, like we did up here, a negative 5.5. So negative 7.7 minus a negative 5.5. Really, we are adding, and we get negative 2.2. So we are, actually, we should probably do it like this. Think of it as, like, what are we, we know we're adding, so I guess that's fine. We can do 5.5. But then we've got to know that we're adding 2.2, not subtracting it. So the negative 7.7 plus 2.2 would give you negative 5.5. Negative 5.5 plus 2.2 is negative 3.3. So then continue from there. So negative 3.3 plus 2.2 is negative 1.1. Plus 2.2 is 1.1. And plus 2.2 is 3.3. All right, let's go to part 2 in this lesson. And that is writing an equation for our arithmetic sequence. So now we are given a sequence, and we're going to write an equation. And remember from that first slide, the vocab slide, equations for arithmetic sequences are written in the form f of x equals mx plus b. M is your common difference. B is your first term when x equals 0. That x equals 0 isn't going to make a ton of sense right now, but it will when we get to the last part of this lesson. I will try to show you, maybe on this one too, what it means. All right, m is our common difference. So remember from the last slide, common difference is how am I getting to the next number each time. Notice that this pattern sequence is getting smaller. 11, 4, negative 3, negative 10. I am subtracting 7 each time. So that minus 7 is going to go right here. X from right here stays in my equation. F of x is just a fancy way of saying y equals. So this is our equation. So B is the first term in our sequence, meaning what is the first number in my sequence? Well, let's go over to our sequence. The first number in our sequence is 11. So here's what this equation means. So when I say x equals 0, let's make a quick t-chart here. If I have x and y, so when x equals 0, so let's start x with 0. So if I plug 0 into my equation, -7 times 0 plus 11 would give me 11, which is the first number in my sequence. If I plug 1 into my equation, -7 times 1 is -7. -7 plus 11 is 4. So that is the second number in my sequence. -7 times 2 is -14. -14 plus 11 is -3. That is the third number in my sequence. If I continued my table, I would continue to get the terms in this sequence. So that is what that means. All right, let's try another one. Our common difference, our numbers are getting bigger this time. -4, -2, -1.5. So they are going from negatives to positives. Again, if you want to do -4 minus a -2.5, that'll give you 1.5. So we are adding 1.5. The first number in my sequence right there is that -4. All right, one more. This time I'm getting smaller. 2, -1, -4, -7. So we are getting smaller. It is a negative. We are subtracting 3. First number in my sequence is that 2. All right. Now, we are going to be asked to find specific terms in our sequence. So this first one says, what is the 51st term in our sequence? So now we're given the first 4 terms, 3, 7, 11, 15. It would take us forever to get to 51 to find the 51st term. So we want to use an equation to help us figure this out. So the first thing we are going to do is write an equation just like we did on the last slide. So I'm going to look at my sequence. It looks like I am adding 4 each time. And the first number in my sequence is a 3. So let's remember from that table we made on the last slide, if x starts with 0, I want you to notice a pattern. So if I plug 0, or I'm plugging them in here for x, 4 times 0 plus 3 is 3. 4 times 1 plus 3 is 7. 4 times 2 plus 3 is 11. 4 times 3 plus 3 is 15. Now here's what I want you to keep in mind. 3 was our first term in our sequence. 7 was the second term in our sequence. 15 was the, skip the 11. 11 was the third term in our sequence. 15 was the fourth. We are trying to find the 51st term in our sequence. Look at our pattern. If I want to find the first term, I am plugging in 0. If I want to find the second term, I am plugging in 1. If I want to find the third term, I am plugging in 2. If I want to find the fourth term, I am plugging in 3. So if I want to find the 51st term, I am going to plug in a 50 into my equation. So 4 times 50 plus 3 will give me 203. So that answer is 203. All right, let's Let's try that again. What is the 24th term in the sequence? -7, -2, 3, 8. So remember, we don't want to sit and count out to the 24th term. That's going to take us a long time. We want to use our equation to find that 24th term. So let's write our equation. F of x equals, we are getting bigger on this one. We are adding 5. And -7 is the first term in our sequence. I'm going to show you how that sequence was produced. X, Y. So if I plug 0 in right here, I get -7. If I plug 1 in, I get -2. If I plug 2 in, I get 3. If I plug 3 in, I get 8. So remember, the first term of our sequence was -7. The second term is -2. The third term is 3. The fourth term is 8. So if I want to find on this one the 24th term, I am going to need to plug in 23 to my equation. So 5 times 23 minus 7. 5 times 23 is 115. Subtract 7, and we get 108. So 108 would be our 24th term. Summary.